Yeah, so there's a solenoid. That side is live. That's down to the that side there is down to the start motor, and that's the trigger wire for the solenoid. If you look closely, it wasn't very well soldered, and they left that little strand of wire sticking out, which is right beside the positive terminal on the solenoid. So, this. Right, so in order to help us understand why we need a solenoid and how the solenoid works, we're going to draw an electrical circuit. And the electrical circuit consists of a battery, positive, negative terminals. And the system is a 12 volt nominal system. One side of the battery nowadays, it's always the negative, is bolted directly to the chassis, and that's to allow us to return the electrons to the battery after they've worked any specific load. And the next thing is our start motor, which was just simply a circle with an M in it. That's the symbol for a motor, and that needs a live supply to work, so let's give it a live supply. Now the problem with this circuit is clearly it's working the whole time, so we need to put a switch in. So let's put a switch in. It's a push to make switch, like what you have on the handlebars of the motorcycle. Now the problem with that is, we have to make the return circuit here for the electrons. The problem with this circuit is, this circuit here will consume a fair amount of electricity. Best guess, average 60 amps when the start motor is kicked in first, and dropping to 30 amps as the start motor starts to turn and crank the engine. Now this switch lives up in the handlebars, so this wire would have to be routed all the way up to the handlebars and all the way back down to the motor, which would make this cable very long. That's the first problem, because the longer a cable is and the more current it carries, the more the voltage drop is going to happen on the line. The more voltage drop is going to become a problem. Second of all, because I'm switching such a heavy duty circuit, the contacts of this switch here will begin to burn. So I'm going to put heavy duty contacts here, and we're going to make sure that this part here is made of copper. Copper is an excellent conductor of electricity. Now I had to find some way of using electricity to open and close this switch. Now electricity can basically do three things. It can make something hot, it can cause magnetism, or it can cause chemical change. Now we don't want to make this switch hot. We don't want to chemically change it, so that only leaves us magnetism. We want to use magnetism to operate this switch. Now if I want to influence this switch with a magnet, there must be soft iron present, and this is made of copper. So what I got to do is braze on some soft iron. Braze that on there. So now I still have my copper contacts, but now I have soft iron. Soft iron can be influenced by a magnet. So how can I make a magnet? Well, any electricity flowing in a circuit always has an associated magnetic field, but will it be strong enough to close this? Well, simply what I can do is, instead of having a straight line conductor, I can have a coil of wire and run that to chassis. Now all I need to do is pass electricity through this wire. When I pass electricity through this line of wire, a very strong magnetic field gets set up here, strongest at the center. So the strong magnetic field here will influence the soft iron and cause it to come down, which will slam those contacts closed, so I'll get a nice clean contact across copper contacts, and my 60 amps can happily flow here. Problem with this circuit now is it's on all the time, so I'm going to interrupt it and put in a push to make switch. Now this switch is your starter switch that lives on your handlebars. This circuit here doesn't use a whole lot of electricity, so I can run this cable, I can route it wherever I need to, all the way up to the handlebars, up to the push to make switch, and all the way back down to the solenoid, and then eventually to earth. because it's not carrying much current, voltage drop is not a problem. When I push this switch, electricity flows here. A strong magnetic field is set up here, which draws down this soft iron into the strongest part of the magnetic field, which at the same time slams these two heavy duty contacts closed. And that allows an awful lot of electricity to flow through the solenoid and onto the start motor. Now you might say, okay, there are other features in there. In other words, there's a feature in there that prevents you from cranking the motorcycle once the gearbox, once it's in gear. So all you need to do there is, okay, let's put a second switch here. And that switch is only closed when the gearbox is in neutral. So the gearbox will actually close this switch. So then there's another one here. None of this works unless the ignition switch is on. So let's make that the ignition switch. So that's a toggle switch. So you toggle that closed. If your gearbox is not in neutral, nothing can flow. Even if you press the starter, nothing can flow. When your gearbox is in neutral, in other words you get your green neutral light, this switch closes, and then when you push your start button on the handlebars, this switch also closes, and that allows electricity to flow, which will close these contacts and cause your starter to operate. And that's basically it. There's your real life solenoid, and there's those two heavy duty contacts. Now these things here, there's your start of coil and end of coil. So let's see, we can see they are a bit of a mess, which sort of explains why the starter wasn't working too well, or the solenoid wasn't working too well. So our solenoid, and we can see here clearly there's start of coil, end of coil, and you can see why the solenoid might have been starting to go faulty. Crazy dirty, and just corroded wires just dropped into blobs of solder. That's one end of the problem. And well, here's the two wires off the solenoid. One is the start of the coil, and the other one's the end of the coil. We already know that the purpose of the coil is to generate a magnetic field which draws the solenoid into the closed position, closed circuit position. So you can see one wire is completely corroded away, and the other wire just has a big blob of solder on it. And what it looks like happened is the cover was pulled back on the solenoid to do a repair on this fella here, but the cover wasn't replaced, and then this wire here, which was original and intact, just got corroded all the way through till you see what you're left there, one or two strands, and that's all that was making an intermittent connection. This is the one that was repaired, but it's clear here, we're going to have a look now, you can see that it was just a big blob of solder just dropped onto a deeply corroded wire and soldered back onto the terminal. Now we've seen the terminals, so I think you can sort of pretty much see that one. So what we're going to have to do now is we're going to snip this, snip the other one, get back to clean virgin wire, so take off some of the insulation, tin the wire, and then clean up the solenoid itself, and then solder the two connections back on. And we're going to clean up these terminals now on the solenoid, so I'm going to use initially some IPA and this fibre brush. So I get some stuff away. Let's see how that goes. Put some fresh stuff on. That would help the other stuff to melt. Yeah, now the old stuff is melting. Right, so I do the same here, and then I'll wick it off. solder is the best thing for carrying heat into solder. Yeah, we got to get rid of that. There's all insulation and everything in there. Bits of the old cruddy wire. So we're going to cut this back to just leave ourselves with a nice clean end, and cut this back. Get rid of that. Now we're going to strip the insulation off these exposed clean wire and tin them. Let's get in and trim and get in and trim. This is the solder we're going to use, and there's some information here. So it's telling you there's 100 grams of solder on this, and the diameter of the actual solder is 0.7 of a millimeter, and it's made up of 60% tin, stenum, SN is the name for tin, 60% and 40% plumium or lead. So that's what makes this stuff so dodgy when you're soldering with it. Like, there is lead in it. But this is where the term tinning the wire comes from. Right, I've gone back a little bit further with this wire, as I didn't like the way the solder was taken to it. That's better now. You can see it. It's wicking through the wire. There's that.